we bring in around about 10 to 12 million pounds a year, which funds the research that we do in this building and also in the Herschel building, so across the whole of the institute. And to say that funds maybe up to 200 people and the research that they're trying to do. It comes from a variety of sources, but very much Cancer Research UK are a big contributor. Cancer Research UK probably give us around about £5 million a year through various forms. Some of them are from directly to the research groups, some money directly to the groups. Other money comes as a sort of infrastructure. So Newcastle is one of only 18 centres across the whole of the UK which is regarded as the Cancer Research UK Centre. And we're also what's called an experimental cancer medicine centre, and that's involved really with more the sort of very much the clinical side. So there are only a limited number of Cancer Research UK centres, and also these experimental cancer medicine centres, and Newcastle has both of these badges. It's a big thing. I said that Cancer Research UK gives us for the work that we do in Newcastle around about £5 million every year. So that is a charity that's coming from people who raise money for us, and clearly think events like the Race for Life, the Relay for Life that we talked about, that goes on in Jarrow at Monkton Stadium, is a big contributor towards that. And I think that one of the positive things is that you can see that money is actually coming back into the local area, because clearly Newcastle is a big centre supported by Cancer Research UK. I mean, obviously when I was talking before, I'm saying £5 million comes in, and you think, well, £5 million to Newcastle, what will my little contribution be towards that? Well, I think the important thing is that it's any contribution, whether it's someone doing being involved in an event like the Relay for Life and raising maybe 10, 50, £100. All those little bits of money add up to the larger sum, and so I think that really is an important message. I mean, yes, if people die, they may leave their estate to Cancer Research UK, and that could be hundreds of thousands of pounds, but actually it's the sum of all of these amounts of money, the £5, £10, all the way up to these very much larger amounts, which really come together and makes the money that we need. I've been involved in the opening event for probably the last 10 years, and I'm really looking forward to being there again on Saturday morning and being involved in the opening. Yeah, it's a great ceremony. You see everyone getting together, and I think actually for people like myself, who's a scientist, you can see the people, not just the fundraisers, but also some of the cancer survivors who are there, and it's nice to sort of to be involved with that whole process. I'm not a particularly emotional person, but I must say that it does bring a tear to your eye, however unemotional type you might be. We know that around about 1 in 3 people in the UK will get cancer at some stage in their life, and probably around about a quarter of people will die of one form of cancer. Probably the biggest change which has been happening over the last few years is this sort of what this new era is called precision medicine, and really that's another way of saying that rather than using therapies in one cancer where you treat everybody with the same type of drug, we're actually now trying to tailor the drugs towards the patient. So that means that if we can individualize the treatment which is more fitting to that particular patient, then it's much more likely that the patients will respond to the therapy. In that area, what we've been doing is we've been trying to identify what individual faults are with a person's cancer, and then knowing that, we can try to design specific drugs which are targeted against them. What we found is that when we've looked back at the genetic makeup of cancer patients in the past, we found that there are some common alterations between certain groups of patients, which are found in one group and not necessarily in another. And so when I say sort of precision medicine or personalised medicine, it's probably not down to one drug for one patient. It's one drug down to a group of patients which are represented within that particular cancer. In the cancer cells that in any one patient, there are lots of different proteins in the cell which sort of keep the cells sort of churning over. And sometimes what we see is that there's a change in one of those proteins which gives the protein a different property. It maybe works more effectively in doing something, and that might give the cancer cell an advantage over the normal cells in terms of how it grows. Right. So we identify what that alteration is, then we try to design a drug which actually hits that particular protein and targets the advantage that it has over the other cells. And then by doing that, we're actually trying to knock out specifically the cancer cell and leave the normal cells functioning as they would normally do. So there are around about 30,000 men in the UK will develop cancer, prostate cancer, of which around about 11,000 will die each year. So it's the biggest male cancer killer. And so obviously, in the past what we've done is we had one or two drugs which have been used to treat these patients. But now, because we can identify these smaller groups of patients which have some common alterations in their genetic makeup in common, then we can try to design drugs which are specific to that group of patients. And I would say that over the last 5-10 years, there's been a lot of developments going on in the drug development field where we've been able to identify cancer targets and try to design new drugs against them. And that's been partly driven by the things that we do here in Newcastle, and other academic centres across the UK and worldwide, but also in collaboration with industry as well. Because to take these drugs into the clinic is very expensive, and we do need to have an academic industrial collaboration. And from that, we've been able to generate a number of drugs which are much more applicable to being used in smaller groups of cancer patients.